Hello there, welcome back to WJEC. Today we'll be looking into the relationship between equations and calculations. So what does chemical equation tells us? Now we have an example of a complete combustion of propane that produces carbon dioxide and water. Now this is a very classic chemical equation to describe the combustion reaction. You have one molecule of propane that reacts with 5 molecules of oxygen, which produces 3 molecules of carbon dioxide and 4 molecules of water. Now, an equation is given. The first thing we have to do is that make sure that equation is balanced. Now, how do we know if an equation is balanced or not? Well, you line up the individual atoms of elements on the left hand side and we make sure that the same number of atoms are balanced on the right hand side. So this equation balances as there are equal number of each atom on both sides. It tells you how many molecules have reacted and how many molecules have produced. It also tells you how many molar amount you require to carry out reaction on a real world scale. So this coefficient that you see, the 5, 3 and 4, they have their uses in the stoichiometry of the reaction. So the number in front of the chemical formula acts as a coefficient, often known as the molar ratio. We can use the molar ratio to find out the required mass of reactant to carry out the reaction. The key idea is that we work out the masses of reactants and products using the molar ratio from a balanced equation as shown above. So the equation that we looked at, suppose you had 15 grams of propane and we want to find out what mass of CO2 is going to be produced. We can use the molar ratio. But the important thing to make note of is that the molar ratio or the stoichiometric coefficient can only be used in the context of calculated moles and not masses. So we can't use masses to predict what mass of 3CO2 is produced or 3 molecules of CO2 produces. We have to first work out the moles and then we can only use that molar calculation to find out the mass of the respected reactants and products that we are interested in. Let's work through this example. Now we have already balanced this equation, but whenever any new equation is given, the first thing that you must do is that you must balance the equation like this. Now step 1, we work out the moles of propane because that is what has been given. So 15 grams of propane divided by 44 grams per mole, which is the relative formula mass or relative molecular mass of propane, that produces 0.341 mole of propane. Step 2, we work out the moles of CO2 using the molar ratio. So now we compare the molar ratio of 1 to 3. Now we are interested in finding out the moles of CO2. Therefore, we times the 0.341 by 3. That gives us a value of 1.023 moles of CO2. The third step is working out the mass of CO2 using the moles times molar mass. Okay, so you guys remember the formula triangle? Okay, so mass at the top and moles at the bottom, so is the molar mass. Okay, so that formula triangle always helps rearrange the equation. So 1.023 mole, which we calculated earlier, times by 44, which is also formula mass of CO2. Okay, make sure you pay attention here that this 44 is not the same as this 44. Okay, so do not confuse these two. Now that gives us an answer of 45 grams of CO2. Let's have a go at some of these questions ourselves. Practice these three and we will go through the answers together. The question states, what mass of carbon is needed to reduce 9.5 grams of iron oxide into iron, which is the iron metal. Now, the first thing we have to do is we balance the equation. Hence, 2 moles of iron oxide react with 3 moles of carbon to produce 3 moles of CO2 plus 4 moles of iron. Now remember, when I talk about these moles, I'm talking about the coefficient. Okay, so when I say mole here, I'm referring to molecules. Okay, so 2 molecules of iron oxide, 3 molecules of carbon, etc. Right, now once you balance the equation, we use the formula triangle, which is mass, moles, and molar mass. Okay, in this case we need to work out the moles, hence we use mass divided by molar mass. So you have 9.5 grams divided by 159.69 grams per mole produces 0.0595 moles of iron oxide. Step 2, we use the molar ratio, so it is 2 to 3. Okay, so it is 2 to 3. So we times 0.0595 by 3, divide whole thing by 2, as the ratio is conducted in terms of 1 to 1. That is why we work out the molar ratio in such fashion. That gives us a value of 0.0893 per mole. Okay, so what to remember here is that you times it by the component that you're trying to find out, okay, and you divide it by the component that has already been worked out or has been given. Step 3, then we work out the mass of the carbon, okay, which goes with the formula of moles times molar mass equals to 0.0893 moles, which we worked out in the step 2, times by 12, which is the relative atomic mass or AR of carbon, gives us the calculated version of 1.07 grams of carbon, okay, which is the mass. Okay. The second question stated, what mass of calcium is needed to produce 30 grams of calcium chloride when reacted with HCl in excess? Now, when you hear the word excess, that means it's in greater amount, in lots of amount. Okay, so first thing you do is you balance the equation. Okay, over here, this is a very simple equation. One molecule of calcium reacts with 2 molecules of HCl, produces 1 molecule of CaCl2 and 1 molecule of H2, right? Remember, it's diatomic molecule. Okay, right. So step 1 is you balance the equation and you work out the moles of calcium chloride. Remember, you start with what has been given to you. So you have 30 grams of calcium chloride divided by molar mass of calcium chloride, which is 110, gives us 0.2703 moles. Step 2, you use the molar ratio to work out the moles of calcium. Okay, now in this case it's very simple, as you're dealing with 1 calcium and 1 CaCl2. So 0.2703 times 1 gives us the same mole as calcium chloride. Step 3, you use moles times molar mass. So 0.2703 times 40.1 gives us 10.8 grams of calcium. So the third question states 18 grams of calcium carbonate is thermally decomposed. What masses of products are formed? Now over here we need to find the masses of both products. Therefore that's CaO and carbon dioxide, calcium oxide and carbon dioxide. Right, so you start with first balancing the equation. In this case, the equations are already balanced. So you straight away work out the moles of calcium carbonate. The mass of calcium carbonate given is 18 grams divided by 100.8, which is the relative molecular mass of calcium carbonate. That gives us a moles of 0.179 for calcium carbonate. Step 2, now we have same molar ratio for calcium carbonate, calcium oxide and carbon dioxide. Therefore, the moles of calcium oxide and carbon dioxide is going to be 0.179. Step 3, you have moles times molar mass. This is the classic formula for working out mass. Over here you have 56.1, which is the relative molecular mass or molar mass of CaO, and 44 the molar mass of CO2. Now look at these two numbers here. You have 10.04 and 7.876. Now if you add these two numbers, that gives us equal weight of 18 grams. Okay, and that is what we started with for calcium carbonate. So this in a way provides evidence that this equation is balanced. And that's it for today. Thank you for watching.